So let's now see the binary search example, how a binary search is performed. And we all know that before implementing binary search in any of the elements, in any array, we must sort that array. So that is the disadvantage of binary search. We can say that element should be sorted, and we need to apply some sorting algorithm on the unsorted list to find out the element in a by for using binary search. So in order to use binary search again, we need sorted list of elements. So list A, in which data is to be searched, so it is sorted already. So these elements are sorted. Now 57, we want to search now the again the same element that we have seen in the other video, and there is this maximum and minimum elements in the starting and ending, as I have already told you in the previous video. So this is the maximum element, and this one is the minimum element, or you can say we need to find out the mid element. Okay, middle element. Now calculate the middle element or the middle index of the variable with which 57 is to be compared. We need to compare it with the middle element. So what will be the middle element? So it will be 0 plus 9 divided by 2. That will be 4.5, and it's this formula that we need to apply, and that will be 4.5, and we'll always take the floor value. And if the element is found at middle position, element that we want to search using binary search in an array will always be uh, we will if we are able to locate that element, that always will be located at the middle point. Okay, so it is not there in the middle point at this in this example. So it will divide this list into further two lists. So why binary search is better than linear search? Because there we have to perform each and every element search. That is called a brute force method. Okay, so we have to perform so many comparisons with all the elements. But in this case, we are dividing the list into two equal halves by using this midpoint. So if the element is not present there in the middle, and it is greater than the middle, so we will ignore this list that is on the left side of the middle element, because our elements are sorted, and our bigger element of this middle element will be there in the this side of the list. So we'll not compare, will not do any comparisons with the left part of this list. Okay, let's see that. So element is 57, which is bigger than the middle element. So we'll make a uh, new starting point, as 11 is less than 57, and lower bound of minimum is pointed at 5. So we'll point a new minimum, that is 5, that is middle plus 1, nothing but middle plus 1. Okay, if if the element that we want to search is smaller than the middle element, then we need not to change the starting point or the minimum. We'll always change the then we'll change the maximum one. So then in that case, the maximum one will be middle minus 1. We'll also see that in this example. So let's run this anyway. So we have new minimum now. First, our minimum was this first point. Now we have new minimum because we have ignored all the elements from middle point to the left side. Now we'll start comparing with the all the elements to the right side of the middle. So our new starting point or our new minimum is this position, element at this position. Okay, so we'll find out a new middle again. Okay, what is our new middle? So our new middle, what is the formula? Min plus max divided by 2, that is 5, plus 9 divided by 2, that is 7. So seventh element will be our new middle. So our element will be compared with this one. Again, we do not have a match here in the middle. So we'll check if element is greater than this middle. So if it is greater, we'll again change the minimum element. Now again we will calculate the middle point, and new midpoint is calculated again. So what is the formula? Min plus max divide by 2. So 8 plus 9 divided by 2 is 8. So 8 is now our new middle. So again we'll compare our element with the middle element, that is 57. So element is found at middle position. This is how binary search is performed. So search is successful as 57 is found. Now we will see its program. So let's see the program of binary search. So first of all, again, we'll write here a header file. We have saved it with binary search, and we'll write our header file. That is the required header file is iostream.h. So we'll write it, and we'll start with our main function. And here in main function again, we'll take a array, and so we'll give the elements of array, any array elements you can take, and then we'll take the element that we want to search in the list, and then we'll take the size of or the number of elements in the array. So we'll use size of operator for that. And so size of whole array divide by size size of, this is an operator, the any one element. So I'm taking first element. So this will return the number of elements. This will return the number of elements. And again, I will call my result from a function called binary search bs, and I'll pass my whole array to this function, and then I'll tell its minimum index, the starting index, just we have seen in the animation, and then the last index. So that will be n minus 1 because we are starting from 0, and then the element that we want to search. So these things we will pass to our function, that is binary search or bs. Okay, this is our main function. So now I'll define my function at top. I can do it at the bottom, but then I have to declare the function as well. So I'm doing at the top now. So I'll write int binary search and take all those variables that are being passed. So this is how we pass an array. Then I'll tell its minimum value or the starting value, and then its ending value, r, let's say r. You can take any variables. Then the element that we want to search. So these are the arguments of our function. And then first of all, we'll compare if the list is finished or not. So if r is greater than or equals to L, then this means the starting is not reduced. Then we need to do the comparisons. So what do we need to do then? We can uh, find the mid. What is mid here? So mid is a variable that will store the middle point, that is starting point plus r minus 1, because it's starting from it will take some extra value, then it's r minus 1 divided by 2. So the middle will be calculated here. So if the element is present at middle itself, then we need to do something. So for that, we'll again apply a if statement here. So if the element is present at middle, so what do we need to do? We'll write here if element at middle. If it is at middle, what is our element? That is x. So if x is at middle, then we need to return this index mid, return this index mid. Okay. And if it is not at middle, then we need to check whether the element is greater than mid, or is it smaller than mid. So if the element is smaller than mid, then it can only be present in the left subarray. And if else the element can only be present in the right subarray. Okay. So first we will do it for the if the element is smaller than mid. So for that we need to use one more if. And here we are doing it with the recursion. Okay. So this is a, you can do it with the iterative method as well, that is also fine. But I'm doing it with the recursion. So if element at the middle is greater than x, this means the element is smaller than x. Oops, greater than x. Then what should I return? So I need to call the same function again, same binary search again, but for different startings and different endings. So I'll call it for the same array, but the same beginning, but the end will be different. That will be mid minus 1. That will be mid minus 1. Okay. And we also need to tell it the element that we want to search, that is our x. Okay. Now this is done, but what if the element is not smaller than this? Then in that case, it will automatically, we can use else, or you can write else here, else return, else return bs binary search. And else means the element is greater than, so we need to change the starting point, that will be mid plus 1, and the ending point will remain same, that is our r. And the element that we want to search is x. So that is what we want to return. What if the element is not present at, and it is not present in the list? then then what should we do? Because we have taken here int and we want to return some value, so what should we return? So there we have ended our first this if statement. After this I will write return, and it is minus 1. So minus 1 will be returned if element is not present there in the list. Now let me save this one, and uh, let's come back to our main function here. Here in the main function, what we are going to do is we are going to use if again. If result equals to -1, the element is not present, and if else it is present at some index, that will be stored in the result. So the result will store this value. So let's do that. We can use if, or we can do like this: result equals to -1. Result equals to -1. Then what should happen? Then there is a condition. Then what should happen? Then see out. I'm going to write it in the short form, not found. Not found. The element not found. Okay. And what if this is not the case? Result is not equals to -1. Result will be equals to mid in that case. Okay. So I'll print there. See out element found at. I'll stop this one and I'll write result here. Just like we did in the previous video of linear search, the same thing. Okay, and that's it. And this is our program. This is our program. So let's see if it works or not. So let me use this header file for get ch and clear screen. So I'll write here new.h, and I'll write here clear screen, and then I'll use get ch here. Okay, let's compile it, and before compiling it, let's save it. So we'll press F2. So our program is saved, and now I want to run it. So I'll press F10 and run this one, and there is no error, and element is found at 3. We can also change the element. Let's say we'll use this here, 40. Okay, 40 we want to search. Now we will compile it again and run it. Hold on. So we'll compile it again. There is no error, and element is not found. Okay, let's see that what's the problem. What if I remove this else? Again, element is not found. Okay, let me make some corrections. So this is our program, and it's working fine now. What was the problem? We have done -1 here, and here also we have done -1. We need not to do that at 2 times. If I passed n here, then only I have to subtract 1 from the r here. Okay, so this is our program, and let's run it again, and element is found at 4th position. So that will be all for today. Thank you. Have a nice day.